Hello everyone. I welcome you all for today's session on machine learning with Python 18 EC 745 for V2 syllabus. Module 1 Introduction Lecture 1. I'm your friend Madhavas, Assistant Professor, Department of ENC, Gaussian College of Engineering, Ramnagaram. Before going to the detail, if you're not subscribed to my channel, subscribe to my channel, click on the bell icon for further notification or share with your friends for their benefits. First, let us see the content. Here we have the first topic is about introduction. Then we'll cover well-posed learning problem. And the second is about designing a learning system. Third, we have perspective and issues in machine learning. Concept learning, in that we have concept learning task, concept learning as a search, finders algorithm, version space, and then we have candidate elimination algorithm, inductive bias, and finally about Python libraries suitable for machine learning. And that numerical analysis and data exploration with NumPy array, and data visualization with matplotlib library there. First, let us see the introduction. So in the introduction, what we can know here is that if we are able to make a computer to learn itself, then it will be helpful to the human world there. That's the important thing, what we are going to cover here. In a simple way, to make you understand about the machine learning concept, let us take a simple example of a baby, a newborn baby. As the baby starts growing, it observes the surrounding world and try to learn itself there. So here, what happens is that the babies start learning it with the help of their own experiences, how it observes, how we are behaving around it. So when you see the babies, they like to learn a lot. Everything they just want to attempt it because they want to know what is that. They want to feel it. They want to experiences that. As we have seen almost all everyone that when they see the light, they just want to touch that. And when they go near it, the elders what they do, we try to avoid it, just seeing that precaution that it hurts it. But if you don't allow the kids to learn by its experience, it always try to touch it. But once the baby touch that particular bulb or a light, it experiences the heat, then it doesn't go to that particular place once again. So as the babies fall down, as the mother take care of that particular baby at the time. But if we continue keep on doing like that, the baby never learn to get up. So at the certain instant of time, the parents what they does is that they allow the babies to stand by itself and learn the process of life. So as we have seen the example of this baby learning itself, self-learning system, we say. So if we generate that kind of a system, that systems are called as machine learning system. And that's what is explained it here. So ever since the computers were invented, we have wondered whether they might be made to learn or not. So if we could understand how to program them to learn to improve automatically with the experiences, the impact would be a dramatic. Some simple example is that imagine a computer learning from the medical records, then it may suggest which kind of treatments are most effective for that particular diseases. It may suggest it. Houses learning from experience to optimize the energy cost based on the particular usage pattern of their occupants. So if you observe the second concept, as we are know, we have to save a lot of power, and during daytime, we don't need that much power. And depending upon the surrounding light and everything, we can automatically on the light or off the light depending upon the light available in that particular house there, or turn on the fan or ACs like that. So home automation systems, what we have. So a successful understanding of how to make computer learn would open up many new uses of computers and a new level of competence and customization. As we can observe in the present world, how the technologies are growing, how the computers are learning by itself. A simple example in Google, Alexa, we use the term and we announce the word or the sound is recognized by the Alexa system, and it performs the operation according to the sound what that particular Alexa instrument here, which we can see it in a television ad there. A successful understanding of how to make a computer learn would open upon many new users of computers and new level of competence and customization. And some of the examples, as I said, was learning to recognize spoken words, a simple example of Alexa advertisement, or बोलने से सब कुछ होता है, a new advertisement of Google. Learning to drive an autonomous vehicle, unmanned vehicle, as we can see, that's one of the concept what it is being developed there, and learning to classify a new astronomical structures in the space, what we can just see, and learning to play world-class backgammon. This is one of the game what we have, how that particular game is learned. As we see, all the human beings are addicted to playing the games either in mobile or a laptop or anything. So how the computer plays with the human, as we are playing, depending upon the level, the competition between the computer and the human, we start playing there. In the initial stage, the computer always either fail level 1 or 2. As the level keeps on increasing, the toughness or the competition between the computer and the human increases there. So this is how, then how that level is being given. All these levels are being programmed by to the computer, and the computer learns when it is playing there. Okay, that's in one way of learning, self-learning, or you have to give the database to that particular computer, and through that database it learns and it performs the operation there. So some tasks cannot be defined well except by examples. So there are so many tasks which cannot be defined, so it can be learned by its own experiences there. So something like relationship and correlations can be hidden within a large amount of data. So machine learning, data mining may be able to find this relationship. So in that, learning of data mining plays a crucial part. So human designers often produce a machine that do not work as well as desired in the environment in which they are used. There are certain instances what happens is that they may not work according to the requirement what it is been designed. So the amount of knowledge available about certain tasks might be too large for explicit encoding by the humans. As we can see, a large number of patients are there and large number of data for that particular treatment of diseases are there, and it becomes difficult for it to analyze and predict it. So the environment change over, as we can see, the environment change from the climatic changes, and the new knowledge about task is constantly being discovered by the humans. As we can see, the new technologies have been introduced, and learning, understanding about that particular knowledges or the task done by the humans, that should be given to the machines there. So it may be difficult to continuously redesign the systems by the hand. So when the changes are happening, and every time frequently, if you want to design or modify the system, then it takes a lot of cost, time, and everything. So instead of that, if you design a general system and that particular general system keeps on learning itself with the help of an experience, self-learning experience, or the database given by humans to that particular machines. A simple definition what we have is about well-posed a learning problem. So how that particular system learns it. So a computer program is set to learn from experience with respect to some class of task and the performance measure. If performance at the task in T as measured by P improves the experience, as we know, I have taken the example of a baby, how it learns through its own experience. Same way, here also, three parameters are defined, that's the task, performance, and the experiences. And what kind of a task is present, and what is the performance improved for performing that particular task when it is repeatedly executed. And due to this, what is the level of experience it is getting experienced. So these are the important thing what we have. So well defined learning problems has these three important features that has to be given to the machine learning: the class of task, the measure of performance to be improved, and the source of experience. Here we have taken a simple example of checker game. So this is a simple board of a checker game, similar to a chess, where we have a coin like this of a different color depending upon the design and everything. So one is white, another one is black, what we have. And the task is what ultimately is to win the game. So checker game, a computer program that learns to play a checker might improve its performance as measured by its ability to win. As we know how much many times it means that performance is getting improved to that particular machine there. At the class of task involving playing checker games, and whatever the experience is getting by winning or losing, that helps that particular machine to learn about that particular checker game there, or it will play against itself and learn the gain the experience. So checker game, what is the rules to playing that? So coin travels only in the forward direction only there. So coin travels only in the diagonal direction. Nowadays the technology has improved, it can travel in anywhere. Here the concept what we have taken was it is traveling in a diagonal direction. Jump over opponent coin means you are killing the opponent coin, that means you are destroying the opponent coin. So only one move per dice. When the dice is thrown, depending upon that, only one move has to be done there. So in checker game, while moving diagonally, player should find all possible sets of moves. So when it is moving diagonally, it should check in all possible directions. That's about forward direction there. And in that, player should choose only one move, and that move will be the target move. So selection of the move, in which direction the pawn has to move, the coin has to move, that becomes the target move there. So a checker game, there is a checker learning problem. What are the things what it has? One is task T, as I said, a task T, playing checker game is the first task. Then how to improve performance, how many times the game has been won against the opponent or playing with itself. Then that will have an experience playing practice games against itself. Or if you don't have any opponent, play with itself. That's a self-learning system to gain the experience and then play with the opponent there. So these are the important thing present in the checker game. Similar way, a handwriting recognition learning problem. So task is what? Recognizing and classifying the handwritten words within the image. So in order to recognize all these things, it has to be classified what are the words written there in the image there. Next one, what we have is performance measure. The percentage of words correctly classified. So what is the percentage of word it has recognized and it has classified that? Then a training experience, a database of handwritten words with a given classification. Then how the particular machine will classify it, because it should have a database, and with the help of that particular database, it would classify the handwritten words. Another example for the well-posed learning problem is about a robot driving learning problem. It means what? Unmanned driver. In simple way, driving on a public four-lane highway using a vision sensor. As we know, when it is unmanned, there must be a camera, that's the sensor in which direction the vehicle has to move. And here they're taken a simple example of four-lane highway. In that direction, if a robot is driving, then how its performance is measured. An average distance traveled by that particular robot before occurring an error. So as it is observed by the human there. Then a sequence of images and steering command recorded while observing a human driver. So how that particular robot get experience, it just observes the manned person, how the steering command is changed, or what is the speed it is being traveling. Depending upon the observation, the robot try to learn it there. So this way, a different learning examples are given to learn about the particular task. Next, what we have is about designing a learning system. So the basic design issues and approach to machine learning are illustrated by designing a program to learn to play checker with the goal of entering in the world checker game. Now here one simple example they are taken is about playing a checker game, and the destination and the target is what? To play it in a world checker game tournament. And what are the things what it has to be done? So choosing the training experience, either with the help of the playing with the opponent or the self-learning, choosing the target function, then choosing a representation for the target function, how the representation is done to go to that particular target function. Then choosing a function approximation algorithm. So approximation is very important because it cannot be fixed that is the destination. So in approximation manner or selection of the approximation algorithm plays an important role here. So in that we have two concepts, that is estimating training values and adjusting the weights. The most important concept in about machine learning, about importance of weight. And then finally comes the final design. So these are the important concepts about the machine learning. what we have covered it today. In the future classes, we'll go to the next important concepts about designing a learning system. So if you have any questions, write down your questions in the comment section. I will reply to your questions. If you're not subscribed to my channel, subscribe to my channel, click on the bell icon for further notification, or share with your friends for their benefits. Thank you.